Okay. Good evening. I am Saranjeevi Rangaraj, PhD scholar from University of Hyderabad. I'm a Prime Minister Research Fellow. This is my PMRF deliverable. I have to teach outside of the university once in a week. So for that reason only, I'm affiliated with NPTL. So this is my final class for the bioelectrochemistry. So we have seen so many topics like how this bioelectrochemistry will be useful in day-to-day life, all those things. Today, I'm going to do the topics which I didn't cover. So usually, how my topics will go, I will do the one overall recap, then some assignment questions we will do, then finally the doubt clearance. So this is how my doubt clearance sections will go. So today we are going to see one overall recap. One. Let me open the. So the one topic I didn't cover in all over the thing is standard hydrogen electrode. So that we will see. Already professor has covered in this thing, but I just wanted to help you that what are the important things that you have to remember in this topic. Then one of the student asked me the question in the doubt clearing section, how this K plus and then Na plus ions, how we are calculating the membrane potential from that thing. So these are the two topics I'm going to cover today. Then we will go for the what is the assignment questions. So the standard hydrogen electrode is nothing but, see, electrode is always we can c- take it into two kind of sense. The reason is whenever I'm going through this anode cathode definition, okay, this itself is having two kind of definitions. If it is a electrochemical cell, like for example our batteries, galvanic cell, all those things will have this anode is considered as a negative end, cathode will consider as a positive end. When it comes to the real life scenario, whenever we are running any kind of gel in the lab, like if we will say that DNA is moving from the negative end to positive end, this ends will be called as, these cells will called as, or whatever the electrical current generated there is called as electrolytic cell. So this we will tell it as, this is cathode, and then this one will become anode. The next thing I wanted to talk to you about the standard hydrogen electrode. So when you talk about the standard hydrogen electrode, there will be two different things. So here we can talk about the AG rod. So this is a kind of rod which is suspended into AgNO3 solution. Then this will be connected through the salt bridge, which is having the high salt concentration when you compare with any kind of half cell. So we always talk in this way. This left side is considered as one half cell, and then right side will be considered as another half cell. These half cells are connected to a salt bridge where the salt concentration is so high. So especially when we talk about the standard hydrogen electrode, how this will be, usually it is having the hydrogen gas pump, and which is suspended in hydrochloric acid solution where the H plus ion concentration will be in unity, and in this inside we will have the platinum rod. Okay, so here also the hydrogen gas supply will be there, then outside also the hydrogen supply will come inside. How they will measure this thing when we compare with the other kind of voltage potential difference, whatever it is that we wanted to measure, these things will be considered as a reference electrode. So here basically we always talk about the bioelectrochemistry as a surface chemistry. This hydrogen electrode is such an example for surface chemistry. What will happen if this is the platinum rod which is inside of the this bulb where the hydrogen gas is coming inside, the surface of the platinum rod get the H plus ion, and we always consider this as in terms of the theoretical way uh, as 0 volt. Why we should consider this as a 0 volt? Say in a real life scenario also, whenever we are talking about any number, we'll should have such kind of reference. We'll take this number variance. In between is the 0, then it start 1, 2, 3, 4, then 5. And this side will be considered as -1, -2, -3. So how we will say this is 1 with reference to 0, it is 1 extra. With reference to 0, it's 2 extra. So that is where whenever we are talking about any kind of millivolt change in the system, or we wanted to see that what is the voltage difference between two different endpoints, we need the standard electrode. So that will be done by this standard hydrogen electrode. The one drawback of this method, whatever we talk, we should always need the H2 gas support. So if you go back and then see me my previous lectures, you can see that what are the alternative electrodes that we are using in day-to-day life, then how that will be helpful for the system that we will see. So this is what I wanted to tell you about the standard hydrogen electrode. And if we go back to the question of one student, the student asked me that how we will calculate the membrane potential in terms of the values whatever they have given. So the very simple formula is del EM plus is equal to RT divided by NF, logarithmic value of M plus outside divided by M plus inside. So what is this about? Why we are concerning about this thing? We'll talk about the cell first, then we'll go to this question. If you talk about a cell, okay, so cells can have more ions. So that is the main reason that cells are having the voltage difference between outside and then the inside. And then the membrane potential, how we will see, there are two ions that we are really concerned about is sodium and then potassium. If you see the sodium, if I label it as blue color, the outside of the sodium concentration is very less when you compare with inside of the cell. And whenever I'm concerned about the sodium concentration is so high in the outside the system if I compare with inside. So how the values will be designed if you talk this as a inside, outside. The inside of the sodium concentration will be 15 millimolar, whereas outside will be 150 millimolar. And then potassium, it's opposite. Inside it will become 150 millimolar, outside it will be 15 millimolar. That's why the M plus outside or M plus inside, whatever we are talking, this in and out concentration. If you go back to this, if you apply these things in the formula, let me do it for the sodium, where professor didn't explain that thing, so I will do it for the sodium first. So del E M plus RT N into L, natural logarithmic of M plus outside divided by M plus inside. So now we are talking about the sodium. Sodium inside concentration will be 10 millimolar, then outside will be 150 millimolar. So here R is denoted as gas constant, that is 3.8.314, and T is the absolute temperature in Kelvin. So normally the body temperature or whatever we are concerned about is 25 degrees Celsius. So if I add 273, you will get 278. And then this is a natural logarithm. If I wanted to convert this as a log base 10, I will introduce the value of 2.303 and divided by number of electrons and number of ions will be 1, and F is the Faraday's constant. We'll get it 496423 or 9650. So if you put the log value, outside is 150, inside is 15, then we'll get a log value of 1. And if you simplify all the data, it will get log 10. Log 10 value is 1. So if you simplify this data, we'll get it around plus 58 to plus 60 millivolt. The same concept, professor has done it for the potassium. There you will get it around minus 90 millivolt to minus 85. Understood? So shall we go for the assignment questions or the whatever the practice question we have prepared? Okay. So I will show you the question. You can put the answer in the chat box. I will see. Then we'll explain that what are the questions are correct and what are the questions are wrong. Okay, this is the first question. For a voltaic cell, which of the following is most true? So the first option is one reagent must oxidize, one reagent must reduce, the two reagent must not be in contact, and all of the above. So if you give this as A, B, C, D. D. Will you please explain why D is the correct answer?
No, sir, in voltaic cell, uh, two electrodes are there,
Mm,
and there are electrolyte solutions,
mm,
and they must be separated by some semi-permeable porous membrane so that current flows through the external circuit. And one is anode, that is oxidation occurs, and one is
mm.
cathode where reduction occurs. And so there must be some one oxidizing agent and reducing agent. And for electrons to flow through the external circuit, uh, they are forced to flow so that current will be passed. So they must not be in contact.
Okay. So in that case, this one is correct. One reagent must get oxidized, and then another one is one reagent must get reduced, and two reagent must not be in contact because, as you already told, it should be separated with semi-permeable membrane. So which means all of the above is the correct. Okay, well, how will you do this question? Following are the delta G value for some reactions. Which of the these represents a spontaneous reaction? Will you please tell me why A is correct then? Why can't be C or B?
No, if sir 0, then it will be in equilibrium. If
Hmm.
positive, that is C, then it needs external energy to become spontaneous. But if it is negative, negative means that is delta G is equal to minus NFE, that is spontaneous process. The reaction will be go to completion in
Mhm.
unidirectionally.
Okay, if I tell you one thing, suppose if you are telling that del G is negative means spontaneous, so what will be the del E value of this thing? It should be positive or negative. If
What
I'm
is the
telling,
value?
what is the question? Suppose the spontaneous reaction del
Hmm.
G value should be negative, you are saying. Then what will be the del E value?
Del U will be positive.
Why? How are you saying the del E should be positive? Well,
Delta G is equal to minus NFE.
yes. So if
If
this should be negative, only if
E
del
should
G
be
is positive, only then the equation will become
negative.
negative. Okay. So let me give you one question. Any of the question didn't ask that thing. Suppose the number of electron transferred is 2, then will you calculate the del E value for this question? You are saying that del G is equal to minus 100 kilojoule. Then what will be the del E value or E value?
E is equal to delta G divided by NF. Delta G equal to 100 kilojoule. So 100 into 10 to the power 3 joule
Hmm.
divided by N is 2 into F. F is Faraday's constant. That is Faraday's constant is, I think, the number is 9 point something into 10 to the power. So that comes to uh, after calculation, what will come, that is the answer.
Okay. So if you want to remember this Faraday's constant, it's just a simplified number 96,500. But
96.
even though the exact value should be 96,342 or something, but for the simplification, we always keep it as 96,500 because
Wow,
whenever
wow,
you are
wow.
people are giving the answer in your exam also that you are going to write in the next one, whomsoever applied. So in
Yeah,
that also,
I have
if you
applied
keep
also.
yeah, if you keep this thing in your mind, that will help you. If the question paper setter is giving you or not giving you the values, you should know.
Yes. Thank you, sir.
Yeah, yeah,
Very good trick.
yeah. You will get approximate value. If you use that this exact value, there will be some changes, but in the options also they will not give much changes, so you can easily do.
Hmm.
Yeah. Okay. Salt concentration in salt bridge is dash than in the offset. Is it lower, equal, higher, or none of the above? Okay. So as I already told, it should be higher. The reason is two offsets that we have talked, whatever it is connected through salt bridge. Unless or until the salt concentration is higher, it will not transfer the electron from this A side to B side. So that is why we need the high salt concentration. Okay. Tell me this one. Select the correct notation for a cell. Have you heard about this one? How we are doing single straight line and then double straight line? Will you please explain it why that B is correct?
No, sir. As far as I remember, one is the phase boundary and double bar is the salt bridge. The meaning in
Okay,
the notation.
okay. So suppose if I give you this one, okay, there is a, what is it, platinum here, and then here it is silver, and both the things are in. Suppose we'll keep it for example. It is in the platinum chloride solution. This is an AgCl solution. How will you give the representation for this thing if you wanted to use these lines and then give? In so many places, professor has used this way of representation. Suppose if I'm saying A is a solid which is in the ACl liquid, and then it is in the salt bridge, and then B is a solid and BCl is a solution. How will you do it for this one?
No, then platinum solid single bar,
Mm,
platinum chloride,
mm,
then double bar,
it's a,
silver uh, double bar, then
mm,
silver solid,
mm,
then single bar,
mm.
silver chloride solution.
Okay. It should be liquid or yes?
Solution liquid.
Okay, it should be also liquid. Only then you can equate the solution. Okay. Now you tell me this one. Which of the following is not true about standard hydrogen electrode? It uses a platinum electrode. Hydrogen is bubbled at a pressure of 1 mmHg. H plus is equal to 1. None of the above. None of the above. Why?
Sir, as far as remember, ওই standard hydrogen electrode, hydrogen is bubbled over one platinum.
Okay, that is true. But did anywhere we mention that it's 1 mmHg?
Oh, I yes, yes.
It's a unity. H plus ion should be in the unity. So it's 1. And then it uses a platinum. That's for sure. Okay. So hydrogen bubble will be created on the platinum surface. But we are not given the bubble from the outside. That is what the trick in this question. So this is the wrong. None of the above will not come.
Okay, so B will be the answer.
PT, yeah. Okay. What is the answer for this question? Which of the following is better oxidizing agent? Okay. Why fluorine gas in that case? Why can't be lithium, metal, potassium, or Ag? So first of all, you tell
Sir,
me what is the oxidizing agent. Then we'll go for.
oxidizing agent, it's have the capacity to accept electron, so it will be reduced very
Yes.
fast as
Yes.
compared to the others.
Mm.
I think, sir, fluorine is most electronegative, so it has the capacity to attract electron from others.
Okay. It is coming under the halogens group, right?
Hmm. Halogen group.
Fluorine, bromine, chlorine, iodine.
Yes.
So in that case, this is the reason. So if you see, the fluorine is 9, the atomic number. So the valency is 1. So the 1 valency, the tendency of accepting the electron is more when we compare with the donating the electron. When you see the outermost cell of the fluorine. That is why we are saying that fluorine gas is best example for oxidizing agent. Okay, this one, pHs. minus log H plus. Okay, you told me now you have listened to my lectures or something. I will ask the same question. Suppose one pH of the solution 8, that you are boiling it. So after boiling it, if you check the pH, will it be same pH or it will be different pH?
Now, does boiling change pH? I think no. If
It's
huh?
okay. It will not change.
After boiling, if hydrogen ion will be added or hydroxyl ion containing some reagents will be added or uh, de-added, then the pH will be changed. How could only boiling change pH?
I told this thing actually already. Boiling in the sense, see, suppose I'm telling you one solution I'm giving you pH 8. Okay, I'm giving you 100 ml. Then I'm asking you, you are checking the pH, it is 8. Then you are boiling. After boiling, without cooling down, you are checking the pH. Will it be safe? Or after this boiling water is after cooling down, you are checking the pH. Will it be 8 or will it be 8? Where it will be 8? Or where it will be less or more?
No, please explain, sir.
Okay, the question is 100 ml, you are preparing one buffer. Okay, that will keep it. So I asked you to prepare a buffer of pH 8. You prepare, you checked it, it's pH 8. Okay, then you are boiling it. After boiling with that heat condition, you are checking the pH again. So this pH will be is equal to 8 or it will be less than 8. Or there will be a change in pH. And then third condition, what you're doing, whatever the boiling is, you kept it for 2 hours to cool down. Then you are checking the pH again. So now lastly, the pH will be 8 or there will be any kind of change.
I think it will be 8. Uh,
And
uh,
finally,
huh?
final after cooling down.
I think 8.
Okay. What about the after boiling?
After boiling also it will be 8.
No. Actually, after boiling, there will be a slight pH change actually. It will not be exact 8. That's why whenever we are using
Acha.
any reagent, after boiling, whatever the autoclave also we are doing, we'll keep it for some time. Then
Hmm.
we'll start using it.
Oh, after boiling, there will be some change of the pH in case of buffer also. We
Yes.
prepared
Water.
buffer in our laboratory.
Yeah.
In need, we boiled, but
Yes.
just after that, we should not use it. We should
In the
wait
hot
for some
condition.
time.
Yeah, you have to wait for some time. You shouldn't use it in that thing. Maybe you
Acha,
can try
acha,
it in your lab. Then you will
acha,
get to know. Usually,
acha.
if you whatever the autoclave will do now,
Hmm,
so we'll prepare some 1 molar some phosphate buffer or something. You prepare
hmm.
and then estimate the pH. Then you do the autoclave. Once the autoclave is done, take it out and then check the pH. Then there will be difference in the pH. It will not be exactly 8.
So after boiling, we have to wait for some time
Sometime, yeah.
for,
Only then you
before
can.
uses.
Yeah, before you let it cool down, then you can use it.
Okay, okay, okay.
Okay. Which of the following does not indicate pH? D. Yes, the D is correct. The reason is phenol red also will indicate the pH. And litmus test, in school days that we have studied, the changes will be there in the litmus. If it is acidic in one color and then basic is one color, pH meter is the exact indication of pH. What is the H plus ion concentration based upon that thing that will give the pH. Okay, osmometer will be used in where? Like which set of people will use osmometer? And what is the indication of osmometer? Whatever it is indicating.
Osmometer is for sir, osmolarity measurement of blood like serum
Yes.
or and there are some methods on freezing point depression.
Mm.
It is used in the clinical laboratory in some reference laboratory for serum osmolarity, that osmometer is available.
Now, what is the indication if the osmolarity more in blood? What is more? For
Is
example, tell me
osmolarity mole means the ions electrolytes will be more.
which one I'm asking. See, suppose if you are saying glucose is more, which means whatever the saccharides that we are taking, the sugar is level more in the blood. So you are saying the glucose levels. So which
No,
means
the osmotically active particles will be more.
which one? That's what I'm asking. Which particle?
Electrolyte, sodium, potassium,
Only sodium actually.
only sodium. Tick, tick.
So whenever
Yes,
the
yes.
sodium is more in the blood, then you will see the osmolarity more.
Yeah.
So that's the thing. Potassium is indication for the kidney disease actually, most probably.
Exactly.
Yeah. And then sometimes if you see the person who got the snake bite also, we cannot estimate the potassium in that case also. So that time also you will see the more potassium.
Yeah.
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 Because snake venom has such kind of phospholipase, which will
Uh-huh.
digest the RBC. So that will
Exactly.
lyse the cell. So whenever
They
the
are
person,
hemolyzing.
yeah,
Exactly, sir. They are hemolyzing agents.
yeah, okay. The direction of flow of electrons and flow of current is considered as. Yes. It's the opposite because we have seen the Daniel cell or whatever the voltage cell that we have seen. If the electrons are passing from the A to B, the current will pass from the B to E. Okay. This one is very easy. This is what we have been seeing. The electrode that donates electron is dash. The electrode that accepts the electron is dash.
That donates electron uh, is oxidized, and that
Yes.
accept electron is reduced.
Yes. Good. Okay. Which of the following is unit of energy?
Sir, joules and
Only.
calorie, both A and B.
Yeah, both A and B. Okay. Which of the following is not true about galvanic cell? Which is
Sir,
not true? Which one?
B, I think.
Yes, it is not an actually it is an electrochemical cell. If they have given it is not an electrolytic cell, then it will be a true statement. So this is
Yes,
a wrong statement.
yes.
But the following statement is false.
A, sir, A.
Yeah, galvanic cell is primarily a Daniel cell, but all the Daniel cells are not galvanic cell. This is the final question. According to Ohm's law, V is voltage, I is current, and then R is resistance. What is the relation? If
A is, sir, A.
V is equal to IR. So that's it for the day, if I'm not wrong. So this is the
Yeah.
last class. I didn't keep much.
Okay.
So do prepare well. And if you need any help, I think I have shared my contact details also already. Am I right? In the chat box. Okay, I will share it again. This
Thank
is
you.
my number, and then this is my email ID. You can contact me at any time if you need any help. Okay?
Okay, sir. Okay. Thank you.
Yeah.
Thank
Thank you.
you. We have very good learning experience,
Yes.
sir, and
Yes.
looking forward for your happy future, happy life,
Yes.
and thank you very much.
Thanks a lot. Thanks a lot for attending. Bye bye.
Bye bye.